As the saying goes, a picture is worth 1,000 words. In Chapter 3, we'll talk about visual displays of data. Section 3.1 is about frequency tables. What we're going to be doing here, or how I like to look at it, is we take something which is really just raw data. And we're going to break our raw data into categories. And we're going to count. We're going to take counts of what we have. And when we talk about frequency tables, when you hear the word frequency, think how many times? How many times did it happen? And the quote for this section says, "The greatest value of a picture is when it forces us to notice what we never expected to see." Thank you, John Tuckey. On your concept map, what I would like you to do is to sketch this chart here. This is a frequency table. And the frequency table here has 3 columns. Your textbook says the frequency table has 2 columns. This tally column is sort of like an intermediary column. Let's say that I was asking members of my class how many pets they had. And as I go around the room and ask them, I'd have these numbers here. Well, I could have 0, 1, 2, 3, or 4 pets. And I would put a tally mark for each time someone gives me an answer of that. And then this last column here says the frequency. And so I have 4 people that have no pets, 6 people that have 1, and so on. Let's just add some information to our table. And down here, I'm going to add a column, or add in my column the total row. And so I would add up all of my frequencies, 4 and 6, 10, 15, 18. There's a total of 20 different respondents, 20 different people who responded to my survey. And so I'm going to add a column over here, and I'm going to call this next column the relative frequency. Okay? And in this first row here, I'm going to calculate my relative frequencies. It's about as pretty as it's going to get here. And I'm going to say 4 divided by 20, which is my total, is equal to 1 out of 5, or 20. So 0.02. 6 out of 20 is equal to 3 out of 10, or 0.30. 5 out of 20 is equal to 1 out of 4, or 0.25. And you could put these in your calculator and just take 5 divided by 20 and you'll get 0.25. And 3 out of 20 is going to give me 0.15. And 2 out of 20 is going to give me 0.10. These are my relative frequencies, and you could think of them as decimals, or you could write these as percents as well. And when I add all of these up, I'm going to get 5 and 5 is 10, carry my 1, 3, 6, 7, 8, 9, 10. So I'm going to end up with the sum of all my frequencies is 1. And that's not a coincidence. It should always be 1. And then I'm going to add one more column over here. And this column I'm going to call cumulative, spelled right below, frequency. Okay, cumulative frequency. Oops, those are not too straight. All right, cumulative frequency. And when I'm doing cumulative frequencies, I'm just adding the first one in the next column. So this first one, it starts with 4. Okay. And then I'm going to have 4 plus 6. That's the total of this column. 4 plus 6 is 10, right? 4 plus 6 is 10. 6 plus 5, 10 plus 5 is 15. Again, I'm just getting a cumulative, sort of like a running total here. And then 15 plus 3, this one's going to be 18. And this last one is going to be 18 plus 2, and I'm going to get 20. And so the total here, of course, is 20. So these two things are matching, right? These two things, when I'm doing the cumulative, better match. They better match, yes. All right, so let's go ahead and look at these two definitions you can add onto your concept map. So what is relative frequency? It's the fraction or percentage of the data values in that category, just like we did up here. And cumulative frequency is the number of data values in that category plus the one before it. All right? Now, before we wrap up this unit, this section, we'll talk just a minute about using bins. Using bins. And this is something that we do when we're creating histograms, which are coming up in the next section, by the way. So this is just a precursor of what's coming up. And what I want to say that maybe isn't intuitive at this point, but it will be soon, is that we can only use bins when we're dealing with quantitative data. That would be data that's either interval or, let me see, what are the 4 types we have? Nominal, ordinal, interval, and ratio. So quantitative, let me just fix this. It's not what I wanted to say. Quantitative data is the only time we'll use bins, and that's going to be when we have what? Either interval or ratio types of data. And to wrap it up, here we go. Here's a look at what a bin actually, how it looks. So you can sketch this on the bottom of your concept map and then you'll be done. So here in the center, this one is a bin display. How do I know that? Instead of just having a single number here, I've got a range of numbers. See how this is ages from 0 to 9. Then it jumps up to 10 to 19, 20 to 29. So these are ranges. Not like over here where I have number of siblings of 0, 1, 2, 3, 4, and 5. And over here, look at this. This actually is quantitative data. This is nominal data, right? It's just names, right? I can still do a frequency chart with nominal data, but when I have quantitative data, I can create these bins, and then I organize them into a chart. All right, we've now completed the concept map for 3.1. Get ready to turn this in and get ready to do the next concept map for 3.2.